Hello everyone, welcome to the CC webinar, and this is perhaps last talk of the year. So today we have Professor Ratha with us. He is Empire Innovative Professor at University at Buffalo. Previously, he was a research staff member at IBM Thomas J. Watson Research Center, New York. He received his BTech in Electrical Engineering from IIT Kanpur, MTech in Computer Science and Engineering from IIT Kanpur, and PhD in Computer Science from Michigan State University. He has authored more than 100 papers in the area of biometrics and has been co-chair of several leading biometric conferences and served as on the editorial boards of many journals. He has co-authored a popular book on biometrics entitled Guide to Biometrics and also co-edited two books entitled Automatic Fingerprint Recognition Systems and Advances in Biometrics, Sensors, Algorithms, and Systems. He has offered tutorials on biometrics technology at leading IEEE conferences and also teaches courses on biometric and security. His research interest includes biometric, pattern recognition, and computer vision. During 2011-2012, he was the president of the IEEE Biometric Council at IBM. He has received several awards, including a Research Division Award, Outstanding Innovation Award, and Outstanding Technical Accomplishment Award, along with several Patent Achievement Awards. In 2018, he was designated as an IBM Research Master Inventor. Recently has been awarded the IEEE Biometric Council Leadership Award for 2019, and he is also adjunct faculty in the department. Thank you, Professor Ratha, for joining us today. Over to you now.
Thank you, Pallavi, for the generous introduction. Good evening, everybody. I guess it's I think, as Pallavi said, this probably I'm holding you from the year-end celebrations in some sense. But let's look at more, hopefully some more exciting things beyond the upcoming holidays that we all need in some sense. So today I'm delighted to be here with you all to talk to you about my work in terms of the trustworthy AI systems. And definitely it is inspired, and probably you will see some link to biometrics, as you heard from Pallavi, that for a long time I have been involved with biometrics. So, but the biometrics and AI, there is a significant overlap, and that's what I would like you to see the connection as well. And more importantly, how we can learn from biometric systems to design trustworthy AI systems is something that is on a daily basis I practice. So hopefully I can give you some hints or some guidelines which you can adopt in your design of AI systems as well. So this is kind of a rough outline. What I'm going to present to you has been done. Several parts of the work have been done in the past, and also, even though I'm presenting it, it's very likely that you would guess that it was not done all by me. I was involved with all this work with a lot of collaborators, and I have the honor to present to you all, but there is a lot of people that have contributed in the background to this work that I'm going to describe to you as well. So we will look at basically some AI sort of what is it, and then the trusted AI systems, and then what are the core pillars in trusted AI systems, and then come to hopefully we will have some time for Q&A, but feel free to stop me, because it's a talk that is non-interactive is the least interesting talk that you would ever get, right? So please feel free to stop me, and let's make it an interactive discussion rather. I'm just guiding you based on my thoughts, But to stop me, I'm happy to take discussion points or your observations in between as well. So, it goes without saying that the current AI systems, whenever we say AI system these days, it's very synonymous with deep learning systems as well as machine systems. So you may see me interchange these ones all through the talk, but there are a large number of applications that we, from morning till from the time we wake up to from the time we go to bed, we are using today already a whole lot of deep learning applications or the AI applications. And somehow there is a missing piece that makes us quite uncomfortable with current AI systems. While they are very interesting, people use it, but they tend to be opaque, non-intuitive sometimes, and very difficult for people to understand what the system is doing. Yes, I like what I see, or I have to use it because of business or other application requirements, but the benefits are going to be more useful or more effective when we can rely on AI, meaning I can trust the AI system. That means the system is exhibiting trustworthy behavior. Trust is a very kind of a loosely defined term. We use trust in daily applications, but or we say, oh, I don't trust this person, or this is a trusted, secure system. So trust gets used in many ways. So I will try to capture some of those facets of trustworthiness as we go along. But it's okay to have the loose definition of trust when we are thinking about how an AI system can be a trusted system. So talking about AI, let's look at what happens in a simple AI or machine learning system. We have tons of training data. Before we get to the training data, there is a user. I mean, obviously, we have in mind or somebody, the user specifies the task and is interested in solving a problem. Otherwise, nothing matters, right? So the user specifies the task, then we collect, or either the user provides or the designers collect training data. We go through a machine learning process where we learn the models, and then the learn function, or the classifier as we call it, gets used for inferencing by the user. And that could happen either on my own machine or on a cloud. That's the larger picture, because when we talk about that trust, it needs to encompass wherever I'm interacting with the system. Wherever I meaning the user, right? So the algorithms differ, machine learning processes, or the what we are showing here, but then there are what do we measure? When do we say the system is acceptable or good for the user? Typically, we relate it to saying that, oh, it is accurate, right? I mean, once we say that, oh, the prediction is good, then the user is happy. But that is just one aspect of the trustworthiness. Yeah, a system that is inaccurate, nobody would like to go near it. So in terms of the larger machine learning or AI techniques, there are, as you know, deep learning is kind of only a smaller part of the learning techniques, as you see on the right-hand side. And there are other methods like decision trees, random forest, or statistical methods like SVMs. I mean, it's hard to believe that we had all these models and system machine learning processes that suddenly we have forgotten and we are all behind deep learning. But nevertheless, deep learning has become attractive because of the primary reason being the prediction accuracy. And we know that some of these other methods are probably a little bit less accurate, but then they had their own, or still they have their own advantages. That's when they get used. Even today, even with the deep learning. So just because deep learning provides high accuracy doesn't mean they are the ones going to rule the world until it becomes trustworthy. And that's the key point that we need to focus on. So as probably you know, any day you open a newspaper, there are tons of articles that talk about issues with the current AI systems. Obviously, if everything is deep learning, you can replace the AI with deep learning or machine learning, whatever you prefer. But they have been reported all over, not only recently. I mean, probably we talk about deep fakes recently, but then there are so many other issues that people talk about when they refer to AI systems not being trustworthy. So let's quickly kind of take a snapshot of some of the key issues, so that, because the reason I picked up these ones, because that's what drives the trustworthy requirements. So first of all, it is often reported that the current systems are biased. They are biased against a particular set of community or people of color or whatever. But it's not always that. There have been people have some of the voice assistants have been collecting data without knowledge of the users, and the chatbots not behaving properly. So these are, while deepfake seems to be catching our attention, these are some of the other topics that have been also in the press related to either being biased against women or black or other behaviors that we would not tolerate from a human. So as we try to make the systems more almost part of human life, we cannot have these issues with AI systems. But let me just kind of take you through. I know everybody is very familiar with biometric, particularly when the largest biometric system is deployed in India. So the UID or the Aadhaar system. But so the reason I bring it up, you will see very soon. This is the one that touches people, every cross section of people, across age, across religion, across whatever gender, across skin color. Everybody is part of a biometric system somewhere. And how did they not have these issues? Definitely they had these issues that we talked about related to AI. Today, when we talk about biometric enrollment or getting an Aadhaar. There are some compulsions, maybe policy-wise or the requirement from the government, but definitely many issues have been addressed far before it became acceptable, not just because the government requires you to have Aadhaar card for many applications. So I would like you to also keep in mind this. I don't know if you can see my right hand part of the chart, which says faces can lie, fingerprints never. So it's an aspect of biometric system that is what we are going to see even in the AI systems. That how can people rely on systems when things don't work? This is not only related to the accuracy, it can be also related to how you can fool a AI system. That's the adversarial attack on AI system, which is a component that we will address as well. So so I wanted to get you to some of these so that we can compare and contrast the biometric systems with the AI systems. So the biometric systems go through as what is called as a trusted identity, and meaning you associate trust with a Aadhaar system because there is some component underlying in it that tells you that it cannot be. What is the core part of it that tells you that yes, that's the reason I can trust Aadhaar, because there is an enrollment and proofing stage before anybody is onboarded into the Aadhaar system. They go through a full background check to make sure that that person doesn't have already an Aadhaar card number. Compare that with something like a Google ID or a Facebook ID, which basically doesn't go through anything. You can have 10 different Google IDs, and it's allowed. It's not illegal. Whereas when you talk about a trusted identity system, you must have certain factors that has to be taken into account, and that's the part that differentiate trusted ID from regular traditional identity management system. They get used afterwards in the similar fashion. They can be reissued, recalled, whatever happens in a password or a Google ID system. But the key differentiator is this deduplication part, which makes that identity system trusted. And that is what we are looking for, similar things in an AI system to be called trusted. So what are the factors I can bring up so that you would or everybody would trust AI systems? So as I mentioned, this is not the first time that we saw bad press coverage about AI. This has been there for a very long time in the biometrics domain. The US government paid a lawyer who was wrongly jailed as a terrorist because some false match of the fingerprint with what was discovered at the scene in the Spain train bombing case. So there was a penalty that the US government incurred as a part of it. And we all know that even though we said the one that the key part that we said that differentiates a biometric system enrollment or a trusted biometric system was the deduplication, that people have found ways to circumvent it. And that is the part that what obviously there is nothing as 100% secure or 100% trusted, but there is that as long as the cases are few, very marginal, then we can accept the system to be uh, trusted or trustworthy. And that's the key point that we would like to learn from these systems to see how we can make it. And I mentioned about the adversarial attacks, and this is the counterpart in biometrics. And these are real cases where people have tried to fool the system in many ways. So I'm sure I will just give you one example of the whole thing that you see in the center, this old person with a hat is this young person in reality. And the person flew from Hong Kong to Toronto, I believe, without being, cleared every system until a human discovered that this is not the old person that we see, because there was some inconsistency in the. So while the face and everything has been masked with a fake mask to say that to give the appearance of an old person, but the hands were not, and the flight attendant who was serving saw that disconnect and figured it out. So the similar issues that we see with today with AI have been present in biometrics, and including some of these either in terms of sometimes we see it in the movies that how things have been broken in by attacking the biometric system, but in reality also it has happened. So largely speaking, a deep learning system can be attacked by many adversaries. The adversaries can be set of people who have strong interest for their own benefit, and they can be your customers, your employees, your computation, even it could be governments involved in espionage, and all of that type of scenarios you can happen. You can imagine that this is what is likely to happen. We will look at hopefully a little later the attack models, but the key part to note, as we just saw in the simple AI system, that there is a label training data, and there is either a deep network model or an architecture that we will try to train. And so the three processes are the training, data, and the network. And all of them could be corrupted to get additional blame to the AI system. And how do we prevent those things is sort of the part of the ongoing research that we are all involved in. So I guess we had a brief look at what is the AI current state of the art. Mostly it is deep learning today, and that is what is called as the narrow AI. It's a single task, single domain, but with what is being claimed as superhuman accuracy. But one of the downsides that or enablers of deep learning is this requirement of large amounts of labeled data. But then you move on to the broad AI, where for a broad usage or broad acceptance of the AI methods or techniques or systems today, it has to be trusted AI. And obviously, it can deal with what is known as also called as a neurosymbolic AI and multitasking, multi-domain, multimodal. All of those are requirements, but the key part as we move from narrow AI to broad AI, we need to look at how it can be trusted. Obviously, there is a larger place called the general AI, which is not even in the horizon in the current set of technologies that we have. So, but let's skip that part and focus purely in what is that we need to do in next several years to be for the AI systems to be trusted. So I want to make sure that I didn't skip one. Yeah. So I don't know how many of you pay attention to these things, what is called as the Gartner hype cycle. So Gartner produces every year a lot of reports, and one of them is around what is called as the hype cycles. It's not only for AI. As you can see, the left one, it talks about emerging technologies, and they have it for practically every business space. So the hype cycle is, as it's called, it goes through from a pure innovative idea, and then it peaks with a lot of people jumping into it. Then there is a disillusionment, just goes through a trough where everybody is disappointed that, what we call in AI, the winter of AI. Then people realize that it wasn't that bad as we thought. So that's where that slope of enlightenment and then mass adoption. So that's sort of is the phase that it goes through. Starts slow, peaks up, and then comes down pretty quickly, and then again ramps back when there is a wider acceptance. The reason I bring up this one is that you can see that there are what is called as a responsible AI, and in the larger emerging technology, which is basically on the slope upwards, means and in the specifically for the hype cycle for AI, it seems to be also quite well observed there. And the digital ethics is a piece that relates to the AI that we will, so whatever is responsible maybe has to be ethical as well. So that's the larger framework, and you can see for yourself your topics of interest, where do they fall in it, and you can also go to the Gartner reports to find out details about different technologies and different applications where they fall in this whole space. So the trusted AI is, as I've been saying, that it's a very loosely defined term. So there have been, ever since AI is coming out of its winter for the second or third time, depending on how you count it, people are getting worried about its impact on the society, and rightfully so. So they are looking at how do we come up with different facets that we would like to see, and that is what is, if you look at the third column here, this is from the paper that I showed you, I'm showing you at the bottom, that there is either it's called beneficial AI, responsible AI, ethical AI, or trustworthy AI. So, I mean, probably responsible AI is in 2 times, trustworthy is 3 times in the table, ethical AI is twice, and beneficial AI is just 1 time. And there are references listed here for that. But the key part to note is that there are different facets that people want out of AI systems. And these principles are what are important for us to know as we go to the real world and deploy AI systems. We need to be aware of these principles or requirements, and these are coming from very thoughtful teams who influence their adoption, the technology adoption in the society. As we have been seeing, for example, the Aadhaar would have been impossible without the government support or government's requirement. So the same is true. Most of these agencies are related to either the EU, Chinese government, US government, OECD, very well-reputed institutions that define what is required for the AI, expected out of the AI systems. And I mean, we will, let's look at the most recent one that came out of the US government. So the requirements listed here are AI must be lawful, meaning must abide by the local laws or international laws, and purposeful, must be used for a purpose. You don't do things that I will collect data and keep it later on. And we talked about accuracy is the prime factor today. Reliable. Obviously, we want a reliable outcome every time. Safe. You don't want an autonomous vehicle on the road that is not safe. Secure, understandable or explainable, that responsible in terms of being traceable, which relates to maybe supporting understandable, and it needs to be transparent. If it has not, even humans are not infallible. We have our problems, but we are transparent. And sometimes when we are not transparent, that's where it becomes an issue. So, and accountable. Whatever I do, I must be accountable for what I'm doing. So this is a set of guidelines that we see coming out for a trustworthy AI system. And the Deloitte has put pretty much similar. As you can see, there are different ways people present, but good to know that there is a lot of overlap between some of these thoughts that come out from governmental think tanks as well as private think tanks. So first, it has to be fair, meaning impartial, robust, meaning reliable, privacy, which probably you can relate it to the previous one as lawful, but sometimes you can respect privacy even without a law coming there. Safe and secure, accountable, and explainable. So some of these ones, as you can see, are definitely being echoed in several places. So what is the larger ecosystem when we are, let's now get down to the nitty-gritties and see where things are. You have lots of people that have data. Then there are different models and the user is sitting there. So what do you expect when the user defines a problem, and how does the rest of the process, the AI system, go about solving that problem? So they have to, if I am the designer, let's say user is a bank, but then the bank will have its own data. But if I am a small store, I won't have all the data. So I would have to rely on some data providers. And also there are a whole bunch of models we talked about, we saw it in the earlier chart, that there are a whole bunch of models. So how do we pick a model? And then once we train, the service provider, if I'm not, I'm a small store, I don't have knowledge about what are the AI models and how do I train them, how do I use them. So it's somebody has to put together, and that's the service provider. And the service provider can be on the cloud, can do it in my premises, or as they are called in-prem, or on a hybrid cloud somewhere away from my premises. So the problem that we have to deal with is that I'm borrowing data from outside world, and there has to be evaluation or contribution for those people that have provided the data, which may not be there. And there may be privacy constraints and the trust and transparency issues. Where did the model come from? Is it a proprietary model that I'm using to fine tune or do a transfer learning based on my new data? So, and keep in mind that ultimately the user will look for an accuracy, but there are many other performance requirements, including throughput, some resource constraint. I mean, not everybody will have a whole GPU, latest GPU farm to use it. That's where maybe or even if the cloud service provider can provide it, I am a very low cost user. I don't have that much budget, so I may not be able to use a very expensive cloud service. Whereas a regular cloud service without GPUs, I may be fine. So these are all the different aspects of the user that, but the key part is that at the end, it must be a fair game for everybody. The user knows where did the data come from. The data providers know how much contribution they made into the model building, so that at times maybe the users are willing to provide the data if they are compensated. So that equation needs to be established. And if the service provider borrows all of this, they need to know what is the legal requirements and how can they be transparent to the user, to the data provider, to the model builder, and so that the whole ecosystem works in a trusted fashion, that everybody knows what's happening on the other side. Remember, when I'm using it, it doesn't mean I have to tell the data provider or the model provider what am I using it for, or my transaction data. What we are saying is that it has to be a transparency in terms of what happened in the process. Rest, I don't have to divulge. There is a confidentiality that the user requires, and because of the business process or what they are doing, that needs to be respected, irrespective of that trust that we are talking about. In fact, that's part of the user's requirement of trust, that the service provider guarantees that it will be confidential. Otherwise, I'm not going to rely on it. So, as we have been talking about, what are the different facets or requirements that we would like to see in a trusted system? We saw many aspects. We will touch upon few here. One, what is called the fairness or the bias, and should be well protected, attack free, and should be explainable, and be able to support provenance. Where did my data come from? Where is the model? What kind of development environment I used? And what are the lineage? Where did the data come from? Data lineage, as well as different components of the larger system, how were they built? So that as the user becomes more and more sophisticated, one can prove to the user that this is the reason why we say it is trusted. But many of these parts probably have an AI component, but they have been around. The lineage and provenance part has been there for a long time. Whereas some of the newer requirements that we see in terms of bias-free or being fair, attack-free, these are the parts that probably needs immediate attention from research and go into the products that we develop based on the research. So when we look at a trust space, we need to worry about not only the research, which obviously is very important, but there are a large number of things that we need to look at when we talk about trusted AI. Obviously, it's about humans. I mean, if it is about AI dealing with machines, probably there will be very little challenge in terms of the trust, because the machine-to-machine trust has been established, as I mentioned, through security technologies. But the public concerns have to be addressed, meaning which are very difficult. How do you handle religious beliefs? That's one of the concerns in a societal. Then there are legislations that have to be, remember the first one of the things we said, trustworthy system have to be lawful. That means they have to follow the legislations that under where the system is operating. And obviously the systems would require data sets. Where do they come from? How large are they? What is the use of them? All of that is part of the data sets problem. And the user's requirements have to be the first and foremost, but not necessarily that we can ignore standards. The standards are the key to be successful, so that we can communicate properly. When I say it is trusted, how does it translate across different systems, different geographies? So that's where the standards have to come in to make us understand that, yes, if I see a particular label on the product that is certified through the standard, then I can automatically get the trusted feeling, or I know that it's a trustworthy already system based on whatever level it has cleared in the standards certification process. So, but nevertheless, we are often focused on the research aspect of it, so all these parts are not independent parts. They need to interact together to make the larger trusted AI system. So let's now go a little bit deeper into the bias and the fair or fairness part. Obviously, a system that is biased is unwelcome, as much as any decision maker that we see in real life, a human, if they are biased or unfair, there is a lot of noise made about that. So the bias is defined as disproportionate weight in favor of or against a person or a group, which is considered to be unfair. And while we talk about bias, the bias has been there in the society ever since. And this is from Wikipedia. the left-hand side, they have quantified 180 facets of bias. So we can only capture only a small aspect of it. And typically bias and fairness are used in the similar context. If it is a bias-free, then we would say fair. But these definitions are very difficult to. In fact, there is a paper that talks about 21 definitions of fairness. So you can see that it is not easy because there are 180 different parameters in a bias framework. But the most important ones that we often worry about are the ethnic bias, ethnicity bias, gender bias, national bias, a religious bias, or a social class bias. So this is often the first part that if we clear these ones, probably we have done a lot of coverage of many of the facets that are shown here. But at the end of the day, bias or a machine learning or AI system is a statistical decision process. So it is statistically discriminating based on what it has seen. So it's not like some God that is coming down from nowhere and saying that, oh, okay, the only way it will be totally unbiased or totally fair if the statistical errors don't exist. But so a bias is a systematic error, but we want to make sure that in that one, we are not picking groups against which the error is very predominant. And so take, for example, as we saw earlier, those press announcements or releases that complain about face being gender biased. We want to make sure that the technology is fair to both the genders. Similarly, you can pick any of the other ones that is it biased towards a particular age group or a particular profession. So many of these things we want to make sure. So there is a protected attribute that whosoever is the minority you don't want to be compromised, and that's what you would like to provide equal service for them as well. And so these are probably, I mean, I will leave a copy of this charts anyway, so that you can look at in these details. How do you, I wanted to get to some of the more non-theoretical aspects of these fairness metrics. And I mean, I guess, how do you, there are many definitions, and how do you measure it, or what tools do you use? And this is where it gets more interesting than those definitions and the error rates. The key motivation is that we need to know that either it's the representation or the errors, which ones you want to be fair, and whether you want equal representation, equal parity, or a proportional parity. That means if I'm looking at a population where 99% my users are male, then the proportional parity automatically, even if I declare the result to be male, take for example the gender prediction based on face. If I know my population is, or my test cases are going to be 99% of the time male, I guess I need a proportional parity. Equal parity will probably, I don't know, it will help. And so sometimes the errors can be punitive or will help some individual. I mean, sometimes it can hurt people. Sometimes it will, I mean, you can, if I did not recognize a criminal, then it is helping that person. But if I wrongly recognize, as we saw that in the face recognition example, that some individual, some congressmen in the US Congress were identified as criminals. That's a hurtful thing. So these are all basically how do you handle the fairness part is depends on who you are in this picture or what is the system trying to address. And at the end, whether do you want false positive or the false negative, I presume that you are all familiar with it, but let's see. We will quickly talk about the errors because the errors drive the measurement for bias. If the system is error-free, then they will be bias-free as well. There is nothing that the people will complain about. The errors can come from improper model, improper data acquisition system. The cameras may not be placed properly for small kids to be imaged, so the errors are coming for them. So these are all different facets of the error, and the bias could be creeping in because of the training data distribution and the test data distribution. If the test data, the distributions are different, then you're more likely to see poorer results. And the quality of the data could be bad quality data that is being fed in compared to what you would normally use. And the model itself could be poor. So the errors could come from very different sources, and we will need to pay attention to how to improve. When we say we need to make it bias free, first we need to know what kind of bias we need to eliminate or improve. We cannot eliminate as long as errors are there. That's the one key part that I would like you all to remember, is that we cannot eliminate errors in a statistical system. This is no way. I mean, if you are particular case you are getting 100%, that's okay, but it's not likely to stay 100% accurate for a long time. So this is again a little bit into the error analysis. Let me see how we are doing on time. Maybe we should stop soon so that you can probably ask more questions and interact. I don't know if there have been any questions in the chat that I'm not able to see as a presenter.
Yeah, so there is one question. So is bias and fairness are the same?
Yeah, colloquially speaking, yes. I mean, bias is opposite of fair, right? So it's, but if you say bias free and fair, I would say the same.
Yeah.
And so, and they all come because of the errors. And again, borrowing from the biometric world, you can, so let's for the time being assume that we have a system that produces a score. Okay, so maybe a face recognition system or a a gender prediction system, whatever is your AI system, it produces a score. And based on the score, I would like to say whether it is I accept the null hypothesis or I reject the null hypothesis. So the could be is that this is a male or not male. That is basically the hypothesis that we are taking. So if the score is above 30, I'm just making up a number, then you say, I would always say that it is male. If it is less than 30, it is female. So when we look at this in a statistical large sample, this one, we will get a male distribution and there is a female distribution. And the threshold of 30 that we drawn here is the T. And based on where I draw the line, I would get some false accepts and the false rejects. But based on error, biometric community has looked into groups, what are called as the sheep and the goats and the lambs and the wolves. And further, it's called the biometric zoo. You can look at the paper, what is called as the biometric zoo. It looks at all of these the errors to characterize which subgroup of people provide good results, who are more likely to be attacked, who are likely to be creating lots of false accepts, and who are the wolves in the system who can basically impersonate into the system. So the same the biometric community did not label it as a bias against a particular subgroup, but they have seen that this exists in the system. So unfortunately, I guess I have a very long set of charts here. We will not be able to go through all of them, but I mean, we can probably stop at some point in the next couple of minutes.
Sure.
So the performance evaluation of the AI system is a critical piece. How do we evaluate? And this is where I'm borrowing again from the long history of the biometric system performance evaluation so that we can compare them, how we can use it. So there is something called as a technology evaluation. That means it's a lab setting. You have an algorithm, you have a data set, and you run it, and you produce a performance metric score, how accurate it is, what is the false accept, could be a confusion matrix, whatever it is, but that's the technology piece. And the other end is the operational piece. How does it perform in the real world? I cannot give you any assurances on that because it's what it is. I can tell you, I can reproduce the results. So in between, there is what is called as a scenario evaluation, where you try to put it in a simulation mode in the real world and observe what kind of errors you get in that context. Because in the technology one, the data is already collected, so you are not looking at live data. Whereas in the operational one, it's totally out of your control. It's in the customer's site. And the scenario one is where maybe you have a little bit excess of both. You make it look like operational system, and you can collect and analyze the data and also insert into the system where you can create a false accept or a false reject so that you can observe the overall system performance. So these errors have an impact on the real operation of the system. And this is where the false reject and false accept can be viewed in as an indicator of why are the, obviously we have repeated so many times, the system will not be error free. But then which error do I focus on? That depends on your application. Just take, for example, if it is just simply I'm trying to check my bank balance, then you want the system to be extremely accurate to log in. That means there may be lots of rejections, false rejections, and people will be very unhappy. So that means your call center call volumes will go up. Whereas other extreme, I am not very accurate and I allow transfers of large amounts of money in the bank system. So suddenly I may have to pay for things that the system did not check properly. So that means I will have a lot of loss on my system. So these errors, while create a path towards bias, also have real impact on the system performance, how it is to the user, what are their key metrics that they would like to observe. So one needs to be aware of this so that when you are trying to compensate for bias, you are paying attention to the real metric that the user is concerned about as well. I mean, obviously you can make let's take the example of what has been reported that the gender identification in lighter skin colors is far better than darker skin. So if you are focused on, I mean, one way is that you make the parity, the equality parity, the index that we talked about, that you make even the fairer or the not fairer, the lighter skin community also be operating under the same error rate as the darker skin. Then is the system fair? Yes, I mean, to everybody it is fair, but to the bank or to the end user, it is unusable. So you have to come up with technologies that can improve the errors of the impacted subgroup to the level of the other groups. You cannot lower other groups to a lower error rate. Maybe that's a good point to stop and have a little more interactive discussions on what your thoughts are, things like that. I would be happy to continue on a different day and a different time again, probably to cover other material that I have. But there's a lot more interesting material that we could look at more clearly at a different time. So let me thank you all for today's opportunity, and we can now probably look at your perspectives and your comments, questions that you may have.
Yeah, thank you, Professor. So, Pallavi has to leave for something. So, I'm Anand Misra. I am a faculty member here. So, I will be coordinating this question answer session. And first of all, thanks for this thought-provoking task, your thought-provoking talk. It was indeed a lot of useful things. We all work in AI, but perhaps most of the time we really focus towards accuracy. But these angles are coming up very nice. Okay, so we have a few questions. So asking like, what are the matrices, metrics for detecting bias in AI models? Like,
Yeah, so I mean, often it is the parity error that we talked about. That I mean, first of all, you have to have a definition of who is the impacted group,
Right.
and within that, I mean, you would like to get some parity. So, in fact, later on charts that I had saw things around. Obviously, it is the error rate that you are focused on. I mean, uh, things like speed are come later, but first and foremost is the accuracy. And when you say that X, I mean, some dark skinned person got classified as a male, it is an accuracy problem. I mean, I may be very fast, it doesn't matter. But if I'm not, so what we have done is run some computations to show how algorithms can be measured on certain aspects. Obviously, you have to know what these classes are so that you can focus on them. So in our phase case, we looked at particularly younger children are supposed to be very difficult to be matched. So gender prediction in ethnic groups and younger children. So we kind of create a data set, ask the algorithms to, report the accuracies. And how do you visualize it? I mean, until somebody tells you, you don't even know that this existed in the system. So that is the challenge that we have to, sometimes these things exist. And so you have to go by what is commonly seen in the community as a bias and check on those aspects outright.
Right. Yeah, so there is another question by Surbhi, who is asking, can bias be incorporated in systems outside biometric applications?
Well, obviously, right? I mean, there is bias in terms of one of the examples I probably did not have, and good that the question came around that, so we can talk about that example. Is language translation. You take this is a very common example cited in the literature. I am or he is a doctor and she is a nurse. And now you try to translate that into different languages and come back. It shows the bias in the gender that always she gets at a, so she is a doctor will never be translated back as she is a doctor when you take it from English to gender unaware languages like Turkish, and you take from English to Turkish and bring it back to English, then she becomes he.
Right. So this bias
is not related to often biometric is because I work in it or I have a deep interest in it. I bring examples for there, but it is there. I mean, for example, you can see the COVID examples, right? Where the COVID seems to be impacting low-income communities. That's another bias in the society, how it is existing.
Right. Yeah, but so this like follow-up question from my side. So this biasness is coming primarily because our data which we are feeding is biased, right? Or is it like we can do
that is
model?
one aspect of it is the data imbalance. If I had a matching data set, again, that's another chart that I have down the line, that if you, I mean, where you can, good part with the data set, I mean, experiments is that you can, when you have large data set, you can kind of create these experiments where you can say that whether my test data set and training data set have matching distribution or non-matching distributions. And then you can see what is the impact on the outcome.
Right. Yeah.
But I mean, sometimes, yeah, you can extreme cases we have shown that, let's say you take the same gender prediction application with 90% male and 10% female, then you can expect that it will perform very well on
Yeah.
male side. But you can flip it around 90% female and 10% male, then it will perform poorly now on males.
Yeah. Makes sense.
So then how do you compensate for it sometimes when it is a cloud service, because you don't know what they trained it on?
That's true. Yeah. So another question, like what is the relation, Beb is asking, like what is the relation between general AI system and bias-free AI system? I think bias-free system. General AI.
General AI is like to do with, I guess the bias is a part of the requirement, whereas general AI is more complex level of decision making that we today don't use it in the regular sense. So that's, I mean, I guess, whereas in today's limited AI applications, we would like it to be bias free. That doesn't, I mean, for example, a gender prediction application being bias free is not a general AI system.
Next question is trustworthy AI, how security and transparency can be achieved simultaneously?
Good question, and I guess one I can tell you is that it's a long answer that you have to wait probably for the next webinar. But the short answer is there are a transparent system doesn't mean you take encryption. They tell you what encryption scheme they use. That is the transparency, right? Whether it is a asymmetric key encryption or whatever. And they also tell you that they are using a 64-bit key or 128-bit key, but doesn't mean it is insecure. Just my telling you that I use 128-bit encryption doesn't mean it is an insecure system. I made it transparent to you so that you can address some applications. Maybe 128-bit is too heavy a load that you don't want. But I'm, as a system side, I'm exposing to you what is the my technology I'm using. But at the end, it is still confidential because the key is not known to everybody.
Yeah, so another question by Vikans. Like deep learning models are vulnerable, and suppose an AI enterprise is using an AI system from different service provider in its production line, and somehow there is a loss that the enterprise starts occurring in their system. Then how enterprise will identify that it's the AI system that is not working on, or which part is losing trustness, like explainability?
Yeah, this is the complex question. I mean, meaning it's a very complex system. You are trying to, I mean, it's where, remember the lineage we talked about. So some of this one will become clearer when we go into more deeper rest of my presentation in some sense. So I guess good question, I would say. And sometimes you can use just to give you a quick answer, one is that you can use blockchain for some of these type of things to understand which ones have gone through your trust evaluation. But when you kind of compose larger analytic engine with smaller pieces coming from different parts, at the end, the weaker module will define what is the overall accuracy or overall trust. So I guess when you are defining it, or I mean, obviously you can do it without knowing what systems you're using or subcomponents you're using. It's as much as like what is the system reliability of the overall computer. You know, there are hundreds of different components underneath it. So the overall reliability of the computer is the weakest one that you have. But then how do you test, or how do you know it ahead of time so that either you improve upon it or you be transparent to the user that there is a component of this level that could be causing you troubles?
Yeah. So last question, Professor. So this is, can we achieve transparency and security simultaneously using blockchain in some applications?
Absolutely. I mean, remember, I mean, I just gave the example, right, of the encryption. Just because something is transparent or explainable doesn't mean it is insecure. I mean, I can say that, again, let's take for a clarity's sake, I say that these two faces match, right? I mean, this is my AI system that said these two faces that were given to it are matching. Then I go on to explain that, look at that, the person has a mole on the tip of the nose, and even though the other person has beard, but this person doesn't have beard, but there are certain invariants that I see, and that's why I feel these two faces match. That's explainable and being transparent. But that does not disclose, that doesn't make the system to be insecure. So all of these are not contradictory goals. How do we achieve them using the right tools is something that probably we should have a deeper discussion at another time.
Yeah. Okay. So thanks, Professor Nalini. So it was really nice interacting with you. Yeah, maybe we can have more sessions with you in sometime future. Wish you a
Sure.
very
You know,
happy.
these are very thoughtful questions, and I appreciate all the discussion from all of you. I'll thank you for your time.
Here in advance.
Same to you all.
Thank you.
Merry Christmas and Happy New Year's to all of you as well.
Thank you.